Hey everybody, let's take a look at another Leetcode coding problem. Today we're going to have a look at question 704 on Leetcode. It's called binary search, and the question goes as follows. So given an integer array of numbers, which is sorted in ascending order, and a target integer, write a function to search the target within the nums array. And if the target exists, then we should return its index within the numbers array. And if it does not exist, then we have to return -1. So below we have a couple of examples. Let's look at the very first example over here. So we have this numbers array, and we have this target value. And we can see that this target value of number 9 is in our input array called numbers. So since we know that this target value is in the numbers array, we can return the index position of the number 9. So remember, the very first number in an index in an array has the index value 0. Then the next one has the index value 1, 2, 3, and then the number 9, which is our target value, has the index number 4. So this is exactly what we want to return, and that's why the output over here is 4. And that is exactly why this makes sense over here. So what about the example below? If we have a look at the example below, example number 2, we have another numbers array, and we have a target value, but this time the number 2, if we search for it in the numbers array, you'll see that it is not actually, wait, let me take red. Where's my red color? There. We don't have the 2 within the numbers array. And that is why we're outputting this -1, because if we remember in the question, it said we should return -1 if the target number is not in the numbers array. Okay, fair enough. So how can we go about creating an algorithm to solve this question? So down over here, we're going to have another example. So let's take the nums array and make one up. So we're going to say 0, 1, 5, 10, 20. And as you can see, this numbers array is in ascending order, just as it says in the question. So that's all right. It's in ascending order. Then in addition to that, we're going to say that our target value is equal to 10. Now, the very first thing that we can do is we can look through each individual number and check whether we find the 10. So the very first number, we know, okay, it's not a 10. Then the next one is not a 10. The next one is not a 10. But then, hey, look, we do in fact have a 10 over here. And that is why we're going to output the index of the number 10 within this numbers array. And so the index, so I'm going to write I over here. The index at the very first number is going to be 0. Then it's going to be 1, 2, and 3. So the index we want to output is equal to 3. And that is exactly how the very first brute force algorithm that we're going to write is going to work. So let's skip to the right hand side and let's write down this algorithm in PyCharm. So what we're going to do is we're going to say that first we're going to define an algorithm, and it's going to be called binary search, just like the question. And it is going to take it as an input the nums array. And in addition to that, it is also going to take a target value. And the output, of course, is going to be an integer, because, of course, it's the index, which is a simple number. So we're going to make it output or return an integer number. So the brute force approach that we just went through on the bottom left-hand corner could look as follows. We're going to just make a for loop. We're going to say for I in range, and then we're going to set the range equal to the length of the nums array. Because of course we want to iterate through all the individual numbers in this nums array. So we need to set the range equal to the length of this array. Okay, that should make sense. Then after we've done that and made the for loop, we were going to check that if the number at the index that we're currently checking is equal to the target value, then we want to return the index I. But if we run through this for loop and we don't have a matching number, then we want to return -1. So let's go ahead and now run this algorithm. So what we can do is say print, then binary search. And we're going to first input the numbers array, which is going to be 1, 3, 4, 5, and 19. And we're also going to have the target value, and that's going to be 19. We're going to take a couple of examples, but let's take 19 first. And now what happens when we go ahead and run this, you can see that we have the number 4 in the console output, and that makes sense because this array has the last number set to 19. And so we have the index 0, 1, 2, 3, and 4. So 4 is the very last index in this array, and it has the target value, so that's why we're outputting the value 4. Now let's go ahead and take the number 3, for example, which is also in our numbers array. And you can see that the corresponding index is actually output, because of course 3 is at the index position 1, which is being output. Now let's take another number which is not in the array, such as 13. If we run it now, you can see we have the -1 output because of course we're running through this for loop, but we're not finding a target value. So that is when the return -1 is given back by the function. Okay, so this is the brute force approach, but let's try and make this algorithm a little bit smarter and a little bit more efficient. Okay, so now let's try and make the algorithm that we came up with before a little bit more efficient. So you know how in the previous attempt that we had, we looked at each and every number in the array. So we, let's say we have the array 1, 2, 3, 5, 16, and our target value is the value 5. Then, you know, we're looking through each individual number until we find the right one. But that is a bit inefficient. We can go about this in a smarter way because we know that the array of numbers is an ascending order, right? They say that within the question over here. So the numbers array is an ascending order. So how about we start from the middle and we check whether the target value that we have is greater than or smaller than the middle value. So over here, we know that 3 is in fact smaller than 5. And since it's smaller than 5, we only really need to consider the values to the right of this, because all the values to the left are going to be smaller than 5 because of the ascending nature of this array. So having that in mind, let's perhaps make a little bit more space on the screen, and let's try and think of how this new algorithm that runs in a bit of a smarter way could work. So we're going to look at the array we had a moment ago. So 1, 2, 3, 5, and 16. And the target value we're going to set to 16. Now in our array, we're going to have two values. We're going to have an A, and it's going to be equal to 0 at the beginning. And we're going to have a B, which is going to be equal to the length of the array. And in this case, it's a length of 5. So now what we're going to do is we're going to calculate the middle of this array. So the middle of this array, of course, is the number 3, and it has the index 2. It has the index 2. So how can we use these two numbers, which are at the outmost sides of this array, to get to this value? It's quite simple. All we need to do is we can create a formula as follows. We're going to write a plus b minus a, and then we're going to floor divide this by 2. Remember, when we floor divide, we are simply rounding down after the division. So over here, when we have a equal to 0, then we have b equal to 5, which is the length of the array, minus 0, and then floor divided by 2, we come to the conclusion that the answer is going to be 2. Because when we floor divide 5 by 2, we got 2.5, but we're rounding down, remember, because of the floor division. Okay, so we're at index 2. Now, what are we going to do at this index 2? At this index, we're going to check if the target value of 16 is greater than or smaller than 3. But we know that 16, of course, is much greater than 3. So what we're going to do is, in the next step, we're going to be adding 1 to this outermost index. So in the next step of this iteration, a is going to be equal to 1, right? And b is still going to be equal to 5. And we still have the same array. So 1, 2, 3, 5, and 16. So now if we use the formula that we had before again, but with these two new numbers, we can put it into the formula. So it's going to be 1 plus b 5 minus 1, and then floor divided by 2. Now what do we get here? So if we have 5 minus 1, floor divided by 2, that's 2. Then we add 1, we get 3. Okay, so we're going to compare the target value of 16 to the number at the index of 3, which is 5. And so we do our check again. And we're going to see that, hey, 16 is still greater than 5. We need to move on. So we're going to add another one to this outmost index a over here. And we move forward. Let's go through this really explicitly because this is exactly what our algorithm is going to do when we write the code. So now we know, hey, a is going to be equal to 2 and b is still going to be equal to 5. And we put it into our formula, so that's 2 plus 5 minus 2, and floor divide by 2. And that is going to be 2. This over here is 3, so this is going to be 1.5 with normal division. But then floor division is going to make all of this equal to 1. And we're going to add 2 to it. And we're at 3 again, which is slightly inconvenient, because we're still stuck at the same number that we were before. Yeah, so we had 3 before, we're still at 3. But now we know, hey, we're going to add another 1 to this a value over here. And now if we calculate all this again, so we have a equal to 3 and b still equal to 5. And the the array of numbers remains the same as it was before. And now we plug all these values into our formula. So 3 plus 5 minus 3, and that's divided by 2. And this is going to be 1 over here. And we add it to 3, so we have 4. Now we're going to go to the fourth index. So this is 0, 1, 2, 3, 4. And at this fourth index position, we have our value of 16. So now when we do the comparison, we see that, hey, 16 is equal to 16, which is the target value. And we can stop our algorithm right there and spit out the index of where exactly the 16 is located within our array. So we get the value of 4 in the output. And that is exactly what we're going to have our algorithm do. So let's go on the right hand side and code this out. We're going to create the function called binary search, and it is going to take as an input the nums array as we did with our brute force approach, and of course it's going to also have the target. Now clearly we also want to give it an output, and the output is going to be an integer value, which is the index. So no surprises up until this point, but then we're going to set a equal to 0. Remember, that was also what we said at the very beginning. Up in the top corner, we said that a is equal to 0 and b is equal to the length of the array. So we're going to write a is equal to 0, and we're going to write b is equal to the length of the nums array. Then we're going to write while the a value is smaller than or equal to the b value, we want to execute the formula that we were executing over here on the left hand side. So what I mean is this formula right here. We need to write it down within our editor. So the index is going to be equal to a plus b minus a floor divided by 2. And then if the number at the index is greater than the target value, then of course we're going to be subtracting from b. So then we're going to subtract 1 from b. And similarly, if, or more specifically else if the numbers at the index is smaller than the target value, in that case we're going to be adding to our value of a plus equals 1. And this is exactly the case that we had over here. Remember how we were adding 1 to our value of a every single iteration? So this is exactly what we have going on in our example. Now, of course, if we would have chosen a different target value, such as 1 or 2, instead of 16, then we would have had the case where we would be subtracting from the b value. But yeah, so that is where these two conditions that we have over here come from. Okay, moving on, we're also going to have another else if over here, and this else if is going to check if the number we're currently looking at is equal to the target value. Now, if that is the case, then we want to return the index. And if we run through this entire while loop and no target value is detected, we want to return -1. So let's go ahead and print out the binary search, and we're going to give an input. Let's use exactly the same input that we have on the left-hand side. So that was 1, 2, 3, 5, and 16. And as a target value, we're going to take the target we had earlier, which is 16. So now if I go ahead and run this, you can see that I get 2 values. Hold on, let me rerun this. Yeah, okay. I get 1 value, which is 4. And that is exactly the output that we had earlier down over here. So this is exactly the value that we're expecting. It's 4, and that is because our target value is in the numbers array, and it's at the index position 4. Similarly, if we take another value such as 2, you'll see that our solution works every time. And we can even have a even number of numbers in this array. So if we take 17 and run this again, you'll see that it still gives us the right solution every time. Let's try it with 3. You can see it still gives us the right index position of the target value. Okay, so that is how we solve this algorithm problem. I hope you enjoyed this video. If you did, then make sure to leave this video a like and subscribe to this channel. It really helps out. And we'll see each other in the next video.